let's get started so that you have plenty of time to work. So it says, so maybe just write this piece down. Just write this piece down. So it says, which model, this is going to help you for today, and this is a good review. Which model best represents a function with this set of values? So this is a set of x, y values here. We have x, f of x is y, guys. That means we have a function of x. It says what is the model that best represents the function, which means linear, quadratic, exponential, cubic, fourth degree, fifth degree. You know what I'm talking about, right, everybody? Okay, and then it says, what is the polynomial in standard form? So we just use our calculator for that. So first of all, to find out the degree of the polynomial, we look at our y values. We focus in on our y values. Now remember, we take differences of our y values. So these y values, these x, y points are in order, so we can look at our y values. Now remember, here's the trick. You've always got to start with the y value that comes after the y value above it. So we'll be doing 1 minus negative 6. What do we get? 7. Very good. 2 minus 1. 1. 3 minus 2. 1. And then 10 minus 3. 7. Were they the same when we took differences the first time? No. So we know it's not linear. So we take differences again. And 1 minus 7. And then 1 minus 1. 7 minus 1. 6. Were they the same when we took differences the second time? No. So we know it's not quadratic. So we take differences again. 0, careful here. 0 minus negative 6. And 6 minus 0. Were they the same when we took differences the third time? Yeah, so it's cubic. So it's a cubic polynomial. So now we type it into our calculator. In list 1, we put in our x values. In list 2, we put in our y values. So I'm not going to pull it up because I can't see my x and y values. So everybody should be practicing it. List 1, so you go stat into edit. List 1, type in those x values. List 2, type in these values. These y values. Then you'll go over, after that, you'll hit stat, over to calculate. Yep, in list 2, you'll type in your y values, and you've got to make sure they match up with their x values. X values. And then you go stat again, over to calculate, so you'll scroll over to the right to calculate, and then down, and since it's cubic, we'll go to cubic regression line, cubic regression line, and cubic. What do you get? Okay, awesome. So it gave you the form of a polynomial, and then it gave us our a value is 1, right? So that's x cubed, and then your whatever c value was 2. What was it? Plus 2. Very good. Does anybody have any questions on how to get that? Since I wasn't very clear on that. Okay. Next problem. These are really important, guys. It's been a little bit of time since we've done rationals, but rationals is a huge part of the secondary 3 core. We've got to be really good at these, and no offense, but you guys bombed it on the final exam. So it's good to make sure we know what we're doing here. So it says, what is the simplified, on the midterm exam. That's what I meant to say. Did I say final exam? Midterm exam, these were bombed. I was crying at home over the Christmas holidays. Okay, what is the simplified form of this function? State any excluded values. So first of all, you've got to realize, do you see how this is a polynomial divided by a polynomial? Yep. When it says simplify, we simplify by dividing out exact factors only. Exact factors. Now if it's connected with a plus or minus sign, it is connected. You have to have that exact factor. However, if it's connected with multiplication, you can divide it out, as long as they're the same. So let's first of all look at the top. Can we factor it? We always factor to simplify. Can we factor the top?
Yes.
Yes. So what's in common in each term? Focusing up here, guys. We're just focusing on top. What's in common?
X.
X. So then left is x squared minus 4, correct? Now we've got to factor the top completely. So we better look. Okay, is this factored completely? Nope, it's quadratic, right? If it does factor further, we've got to keep going. So we're looking for what multiplies to be -4 and adds up to be 0, right? 2 times 2, right? Negative 2 times 2 is negative 4, and negative 2 plus 2 0. So because our a value is positive 1, we can quick factor. So the top became x, then this factored to become x minus 2, right? And then x plus 2 because of that positive 2. The top is factored completely. Any questions? I'm going to change colors here. So now we're going to factor the bottom. The bottom is x squared plus 2x. So let's factor out what's in common. The first thing in common is x. So then left is x plus 2, right? Now we're not going to start dividing anything out until we've stated the excluded values. So now think about it, guys. If I said I'm going to plug in a bunch of numbers here, are there any numbers we can't plug in? That's what excluded values mean. Can't we not divide by 0? If you put it into your calculator, 2 divided by 0, your calculator says error. That's because you cannot divide by a 0. Does everybody understand that? There can be a 0 on top. 0 divided by 2 is 0, but 2 divided by 0 does not work. So guys, the whole bottom cannot equal 0. So what values would make the bottom 0? Negative 2 and 0. If we plug in 0, isn't 0 times something 0? Okay, so you would say, okay, so x cannot equal 0, and it also cannot equal negative 2. And now we can simplify. So now we can divide out exact factors. We have an x on top. Do we have an x on bottom? Yes. We have an x plus 2 on top and an x plus 2 on bottom. They divide out to become 1s. Remember, they divide out to become 1s technically. So now we have 1 times x minus 2 times 1 on top. So isn't that just an x minus 2 on top? Now careful, because it's not always going to be on top. You have to be careful. On bottom we have 1 times 1, right? So just 1. So isn't that our answer? As long as x does not equal 0 or negative 2, there's our final answer. Questions on that? Okay, next problem. Write it down. We should be able to just plow through this like crazy people, get it right. Unfortunately, on our midterm exams, like I said, not so hot. So we have a rational divided by a rational. Now there's like 25 different ways we could go about simplifying this. First of all, we do have a lot of properties of exponents going on. I'm going to deal with that, I guess, first, and then divide out. Now there's a lot of ways to do this, but I'm going to do it that way. So I want you all to focus on this piece. Isn't all this stuff being raised to the negative 1 power? So we've got to say to ourselves, we know every single thing in parentheses is being raised to the negative 1 power. That, and that. So I'm going to rewrite that piece that I just highlighted. Isn't that a to the negative 1? B to the, raise the power to a power and you multiply. 2 times negative 1. Negative 2, and then c to the negative 1. Do we have any questions on that piece? Okay, let's go with the next piece. So I'm going to highlight this in green just so we can keep our eyes. So we still have times a, b, c. So we have times a times b times c. Now I'm going to just continue on top for a second to simplify that. So when you multiply the same base, what do you do with your exponents? When you multiply, you add, right? So isn't this a 1, a 1, a 1? Do not miss it. Do not call it 0. That's not true. There's always a 1. So with a's, 1, negative 1, and 1. So we have a to the 0 power, right? And then negative 2 plus 1. B to the negative 1 on top, and then c to the 0, right? Any base raised to the 0 power equals 1. Not the exponent's 1. That's wrong. The whole base becomes a 1. The whole base becomes a 1. You understand that? So cupcake to the 0 power is 1. Anything to the 0 power is 1. So all that's left on top is b to the negative 1. Are we all comfortable with that? Now on bottom, we have all this stuff being raised to the 2nd power. So we would distribute the 2 through to each of those. Raise a power to a power you multiply. So we have a to the 4, b to the 6, c to the 2nd. Now we're almost there. Our final step is to simplify. So we have a b on top, a b on bottom, right? When you divide, then you subtract. You always subtract the top from the bottom. So we really have b to the negative 1. you take the top minus the bottom, and it's positive 6, right? So minus 6. So I just pulled this up. Does everybody understand that so far? So really on top we have b to the negative 7, true, over a to the 4th, c to the 2nd. Now, you have to really be good, because you have to say to yourself, we cannot leave our final answer with negative exponents. So we know if we have a negative exponent, you can take it, flip it over a fraction, and it will make it positive. Now, does the top just magically go away? No, there's always a 1 there, right? So on top there was a 1, left. On bottom we have a to the 4th, c to the 2nd, and now b to the positive 7. Questions? Get it right, guys. Get that one right. I know you can think on that advanced civil level. Questions? Okay, just a couple more. This one. What is the simplified form of this? 3x minus 6 all over 9x squared plus 81. What is the simplified form? So once again, you say to yourself, I have a polynomial divided by a polynomial. I will see if there are exact factors in common. But to be able to know that for sure, we've got to factor the top. So we're going to focus, factor out the top. What's in common? 3. So then left is x minus 2, correct?
Yeah.
On bottom, we have a, what in common? Just a 9, right? Pull out a 9. And then left is x squared plus 9. Now we've got to check. Does this factor further? Let's go off to the side. Well, multiplies to be positive 9 and adds up to be 0. 3 times 3, right? But that's 9. That's not 0, right? This would have to be negative. But does negative 3 times positive 3 equal positive 9? So that doesn't factor further. So we're done factoring. Does everybody understand that? Okay, so now we have to, it just says what's a simplified form. It did not say state any excluded values. However, we know we would say it cannot equal this piece, not 9, right? 9 is never going to equal 0. There's not a variable with it, right? Does everybody understand that? But this piece could equal 0. We'd set it equal to 0 and solve, right? So then we'd subtract 9, take the square root, plus and minus 3i, and not allowed, right? Does that make sense, everybody? But we're just simplifying. Was there anything in common? Good. Doesn't 3 and 9 divide by 3? So this divides by 3 and becomes a 1. This becomes a 3. So our final answer would be 1 times that, which is just x minus 2. And then on bottom, that's just 3 times x squared plus 9. And they may or may not multiply it in. If they don't specify, this answer would be acceptable. Does everybody get it? Okay. It's been a while. So this one's a long one. Write it down. So it says, what is the quotient of x squared minus 9 divided by 2x squared plus x minus 1 divided by x squared minus 3x over x squared minus x minus 2? So what I want you to notice is we have a rational being divided by a rational. Now, we know how to multiply rationals. You just factor and multiply straight across, divide out common factors, right, everybody? Well, dividing fractions is easy as pie. You flip the second fraction and multiply, right? So isn't this our second fraction? This is our second fraction, so let's flip it. So let's put this x squared minus x minus 2 on top. And then on bottom, we'll have x squared minus 3x. So we flip the second, and now we're just multiplying, not dividing. Same thing as division. Questions on that? So now to do this, did that confuse anybody? Okay. So now, this is no longer there. We're looking at this times by this. So now to do this, to multiply, we have to have it in factored form. So I'm going to do it in colors. Let's factor this piece. We just factored this a second ago. Didn't it factor to be x minus 3 times x plus 3? Okay, we just factored that. Any questions? I'm going to keep it in order. On bottom, we've got to factor this piece. So let's quickly do it. Well, multiplies to be a times c, negative 2, and adds up to be 1, right? So that's 1 times 2, and that's negative 1, right? This does not quick factor, so we've got to drop and break. So we drop down our end terms exactly how they are. So we have a 2x squared, we have a negative 1, and then we break down our middle term. So then we're breaking down our middle term, rewriting it as those two factors, but as an x. So minus 1x plus 2x. Then we group the first two terms, group the last two terms, and factor. We should be excellent factorers because secondary 2 shouldn't even pass. You can't factor, and here you're just supposed to be applying factoring. So we factor out an x, left is 2x minus 1, right, people? Are we all following still? Factor out, oh, don't say there's nothing in common. There's always a 1 in common, right? So then left is 2x minus 1 is my safe haven good, yes, right? So I pull it out. So we have 2x minus 1, and then left was x plus 1. Is everybody comfortable with that? We factor this piece, so I gotta give myself some room, so I'm erasing this. So now we're going over here and factoring this top piece right here. I'll do it in purple, I guess. So we're looking for, it's quadratic, what multiplies to be negative 2, I'm looking up here, and adds up to be negative 1, 2 times 1 again, right? This time it's negative 2. Can we quick factor? Yep, isn't it A1? So we're going to be multiplying by that factor to be x minus 2 times x plus 1. And on bottom, this is an easy one to factor. What's in common? X, the left was x minus 3. We have it all factored. Is everybody good? Now we can start dividing things out. So we're just multiplying, so think about it. If we multiply straight across, it doesn't matter order. So let's start simplifying, dividing out exact factors. We have an x minus 3 on top. Do we have that on bottom? That divides out. It didn't say we had to exclude any values. On top, we have an x plus 3, anything like that on bottom. Nope. X minus 2, nope. X plus 1. Those divided out to become 1. So left on top was x plus 3 times x minus 2. Left on bottom was x and 2x minus 1. Now this answer would be acceptable, but they may multiply the top back together and they might multiply the bottom back together. Does that make sense, everybody? Yes. Oh, okay, awesome. Questions? Okay, that's it. So here's the catch. There's a lot of things we can't do today because we haven't learned every single thing we've been supposed to learn because you simply don't have enough time to learn everything. So there's going to be a few things I'm going to have you cross out because even if I tried to hurry and teach it to you, you wouldn't remember it anyways. So you're doing pages 26 to 30 right now on just forever because we're not going to get to it before we can. On page 26, you're only doing problem number 1. Now, you might look at those on problem 26, on page 26 and say, I could multiply those out. Because you'll see something like this, like x plus 1 to the 7th power. We could multiply that out, right? But that would take us a long time, but I know you could do it. However, there's a trick, there's a thing we could have learned this year, which we just did not get to. It's called Pascal's triangle that makes that a lot easier. Because I started to multiply that out just to see how hard it would be for you guys, and it gets messy as all heck. So I'm only making you do problem number 1 on page 26. The rest you can cross out. On page 27, on problem number 3, it's multiple choice, but I literally do not think any of those answers are right. So you'll just write down your own degree. Like we did in the first example today, you'll write down your own equation using your calculator, stat 1. I swear I could not figure out what the right answer was. I sat and worked on it for like an hour. So just use your own. I think they must have messed it up. And then come to the stage for review party tonight. Ready, set, go.